Welcome to the AI Research Roundup. I'm Alex. Today, we're looking at a paper published May 5th, 2025, called LLaMA-Omni2, LLM-based real-time spoken chatbot with autoregressive streaming speech synthesis. This paper introduces a new series of speech-language models, or speech LMs, which are AI systems that can understand speech and then talk back, all in one go. The exciting part about LLaMA-Omni2 is its ability to do this in real time, very naturally. It uses a speech encoder to process what you say, and an autoregressive streaming speech decoder to generate its spoken response. Autoregressive means it creates speech sound by sound, and streaming allows for continuous output, making conversations flow smoothly, even with surprisingly little training data compared to other models. And if you want to dive deeper into this LLaMA-Omni2 speech-language model, well, the LLaMA-Omni2 repository is up on GitHub. You'll find all the code for this spoken chatbot there, plus a detailed README file. This README provides installation steps, quick start guides, and tells you how to run the Gradio demo, which is a simple way to interact with the chatbot, or do local inference. That means running the model on your own computer. So it offers pretty much everything to get going if you're interested. Alright, so this first figure gives us an overview. On the left is the LLaMA-Omni2 model architecture. Input speech hits a speech encoder, then a speech adapter, which refines this data for the large language model. The large language model generates text and also LLM hidden states, its internal working data. A gate fusion module then merges these hidden states with text info. This goes to a text-to-speech language model to create speech tokens, small sound units, that a flow matching and vocoder system, like a digital voice, turns into audible speech. The right shows the two-stage training. First training speech understanding and generation separately, then together for smooth speech-to-speech. Alright, now Table 1 really puts some numbers to that performance we've been discussing. It compares LLaMA-Omni2 with other models on tasks like spoken question answering, testing both speech-to-text, or S2T, which is understanding spoken input, and speech-to-speech, S2S, which is having a full spoken conversation. Key metrics include accuracy, where higher is better, and ASR, WER, that's automatic speech recognition, word error rate. A lower score here means the AI's spoken output better matches its intended text. LLaMA-Omni2, especially the larger versions, generally shows superior results, including more natural-sounding speech and good real-time latency. Okay, so building on those general comparisons, Table 5 here zeroes in on the LLaMA-Omni 2-7B model and looks at how the amount of training data impacts its abilities. We're seeing similar metrics: accuracy for spoken question answering, and automatic speech recognition word error rate. But we also have ChatGPT score for speech instruction following, which, like accuracy, is better when higher. The table also shows if the training data used multi-turn dialogues, meaning back-and-forth conversations. It seems that using 200,000 multi-turn dialogue samples gives the best speech-to-speech performance. For instance, a 4.15 ChatGPT score and a low 3.26 automatic speech recognition word error rate, suggesting this amount is quite effective. Okay, so we've seen how training data affects accuracy, but real-time conversation also needs speed. Table 6 details the latency, that's the delay, in milliseconds for various LLaMA-Omni2 models. It breaks down time spent by the large language model, the text-to-speech part, and the flow matching plus vocoder. It also explores different R and W values settings for its read-write strategy, which affects how speech is streamed. For the LLaMA-Omni 2-7B model, with R at 3 and W at 10, total latency is about 583 milliseconds. Larger models show slightly more delay, but these numbers generally support real-time interaction. As we've seen, LLaMA-Omni2 really pushes the boundaries for creating spoken chatbots that can hold a conversation in real time, and do it naturally. This kind of work is so important because it moves us closer to AI that we can interact with as fluidly as we do with each other. Thanks for tuning in to the AI Research Roundup. I'm Alex, and I'll catch you next time.